are recording. Good. All right. So there are three trigonometric ratios that we're going to be discussing today. There are more than three, but for geometry, we will only be talking about three of them. Once you get to pre-calculus, you'll explore more, but not until then. So if you have a triangle, call it ABC, then the sine of each angle in ABC is the ratio of the length opposite that leg, across from it. It's the ratio of that to the length of the hypotenuse. So for example, if we are talking about the sine of angle A, here's angle A, we would take the length of the side across from A, which would be side A. And then we would place that over the length of the hypotenuse, which is always going to be C. So basically, whatever number this is to that is going to be the sine ratio according to this angle right here, which is A over C. Now, the sine of B will be a little bit different because if you look across from angle B, it's no longer side length A, it's now side length B. But you'd place the length of side B over the length of the hypotenuse. Now, if we're discussing things like a 45, 45, 90, or 30, 60, 90, I want to try to relate this to what you know already. So back of a tardy slip is going to work perfect for this. So if we have, let's say we got a 30, 60, 90. And my 30-degree angle is up here, okay? And I've got angle A, and the side length across from it is 4. First of all, what's the side length of the hypotenuse in relation to the short side in a 30, 60, 90? Short leg, hypotenuse, what's the hypotenuse going to be? Twice. So what's it going to be? 8. Okay. Now, that means that the sine of this angle here, A, which is how many degrees? 30. So we would say that the sine of angle A is equal to 4 over 8. What is 4 over 80 as a fraction? 1 over 2. 4 over 8. Yeah, 4 over 8 would be 1 over 2, 1/2, 0.5, however you want to call it. We also happen to know how many degrees that angle is. It's 30. Which means instead of writing sine of angle A, we could say sine of 30 because that's how many degrees angle A is. Pretty good with this so far? 30 degrees for that? Okay. So we would say that the sine of 30 is equal to 1/2. Now, I want you to get your calculators out for a second. It doesn't matter if you're using a scientific or a graphing. I'm going to grab a scientific as well so I can make sure that we're all in the right setting. So whatever calculator you're using, up next to the second button, this works for it's in the same location on the scientific as well. Hit mode. And for degrees, where you've got the option between radian and degree. This is also on the scientific calculator. Make sure you are on degrees, okay? There are two ways that you can measure an angle. One of them is in degrees, which is all we've ever used, and the other one is in radians, which you have not used yet. You will use that in pre-calculus. Make sure, though, that this first option is on DEG for degrees, not on rad or grad. Make sure you're on deg for degrees, okay? And then you can hit second and then mode again, that'll quit. So second mode will quit you back to the main menu. Now, we just said that the sine of a 30-degree angle is equal to 1/2. So I want you to go to the sine, cosine, tangent buttons, and I want you to find sine and type in sine, and then type in 30, and close the parenthesis and hit enter, and what does it tell you? SIN. 2 buttons above 7. It says 0.5 or 1/2. You type in 30 after that. Should say 0.5 or 1/2. Yeah. And we just show that the sine of 30 is equal to 1/2 based on this. Now, this angle down here is how many degrees? 60. Okay. That's a 60-degree angle. What's the length of this right here? Yeah, 4 times the square root of 3 or 4 root 3. So if we're talking about the sine of angle B, call that B, sine of angle B, we would say that the sine of angle B is equal to the length opposite from it, which is 4 root 3 over 8. So we would write 4 root 3 over 8. Now, we already know that 4/8 is 1/2, so that would be 1 root 3 over 2, or just root 3 over 2. So root 3 divided by 2. On your calculators, type in the square root of 3, and then divide that by 2. And you should get a number that's about 0.866025403. It just keeps going, right? Yeah. 0.8660, yeah, right? That's what you get. Now, this number here should be equal to the sine, it is the sine of angle B. How many degrees was angle B? 60. So now I want you to type in sine 60. It should be the exact same thing. Hey, look at that. It's the exact same thing. So all we're doing is we're taking side lengths from right triangles and comparing one length to another length, and that translates into the calculator as a sine or as a cosine or as a tangent, because those would be different comparisons between other sides. So that's what it is. Now, here's the thing about special right triangles. The two special right triangles that we learned about have these kind of nice, clean relationships with root 2s and root 3s and like twice the length of the short leg and all that good stuff. Those are things that we can memorize. The fact of the matter, though, is that everybody listen up, every single right triangle is a special right triangle. Doesn't matter what the angles are. Every angle and every right triangle will have a set relationship between the side lengths. We won't memorize them. These are the only ones that I would suggest memorizing, 30, 60, 90, 45, 45, 90. But it doesn't matter what kind of right triangle you have. There is a set relationship, because if you think about a triangle that is a 30, 60, 90, and it's small like that, if I were to draw another 30, 60, 90, that was bigger, it would still be a 30, 60, 90, which would make it similar to this one, right? So if this was 10, this would be 20. And the sine of 30 degrees would still be 10 over 20, which still reduces to 1/2. So no matter what, those relationships between the side lengths will always be the same, because every right triangle that has a certain amount of degrees is similar to every other right triangle that has the same amount of degrees. So those relationships between the side lengths will always be the same, which is great. That makes every right triangle a special right triangle, because every single right triangle with any amount of degrees has a special relationship, a set special relationship between all the side lengths, if you compare them. So that's what trigonometry is. It's not some crazy thing. It's just ratios. It's comparing side lengths. So the next one after sine is called cosine. Cosine is a different relationship. Sine is opposite over hypotenuse, comparison from an angle. Opposite meaning look at an angle, look across the triangle to the side that is opposite from that angle, and then put that side over the hypotenuse. Cosine says if you have a right triangle, then the cosine of each acute angle is the ratio of the length of the leg that is adjacent to that angle over the hypotenuse. So for example, if you look at angle A, the length that is adjacent, by the way, there are two adjacent sides to angle A, B and C are both adjacent. However, one of them is the hypotenuse. So when we're talking about adjacent, we're talking about the side that is adjacent that is not the hypotenuse. So adjacent here would be B, and hypotenuse is C, because hypotenuse is always C. What do you notice about the cosine of A and the sine of B? What do you notice about the cosine of A and the sine of B? It's the same ratio. So that means that the sine of 30 should be equal to the cosine of 60. The sine of 30 was 1/2, wasn't it? Okay, so sine 30, type in cosine 60. Oh, it's the same thing. Because you're comparing the same two side lengths, but you're comparing the same two side lengths from a different vantage point. But it's still comparing the same two side lengths. Because if A is here, and the adjacent side for A is here, and the hypotenuse is here, the adjacent side for this angle up here is the same as the opposite side for this angle down here, across, opposite, adjacent. So it's all a matter of perspective, which also makes the cosine of B, if you look at angle B down here, the adjacent side to B is not the hypotenuse, so it's side A, over the hypotenuse, which is C. And the cosine of angle B is the same as the sine of angle A, because you're comparing the two same side lengths just from a different starting point and using a different ratio. But that different ratio ends up creating the same two numbers being compared. Any questions so far before we look at tangent? All right, let's think about tangent for a second. So tangent is the third one we're going to learn about. So we got sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent. If you have a right triangle, the tangent of each acute angle, by the way, we're talking specifically about the acute angles. We are never, and this is actually really important, I'm going to back up a little bit. Every single one of these references specifically each acute angle, or I guess because it's a triangle, both a right triangle, both acute angles. There are two acute angles in a right triangle. The third angle is not acute because it's a right angle. We do not use the right angle in trigonometry. We use only the acute angles with trigonometry. Don't use the right angle when you're dealing with sine, cosine, or tangent. Use the angles that are less than 90, the acute angles. Okay, now back to tangent. This is the ratio of the leg opposite to the ratio to the leg that is adjacent. So for example, if we're looking at the tangent of A, you look at the side length across from it, the opposite side, which is length A, side A, over the side adjacent, B. So the tangent of A is going to be A over B, right here. The tangent of B will be the opposite to angle B, which is side B, over the adjacent to angle B, which is side A. So tangent of B is B over A. So tangent of A is A over B, tangent of B is B over A. The tangent of the two different angles in a right triangle, the two different acute angles in a right triangle, are inverses. Reciprocals, not inverses. They're reciprocals of each other. There is a way that you can, there's a phrase that maybe you've heard before, maybe not. I bet your parents would remember this one as well. It's off to the side here. Memorizing trigonometric ratios. The easiest way to remember it, and this has been used for, I don't know, probably 100 years, is the phrase called SOHCAHTOA. Anybody ever heard that before? SOHCAHTOA? I'm seeing some nodding. Some people have seen it. Some people probably heard it before. Yeah, if you ask your parents what SOHCAHTOA is, they probably, some of them might have like a post-traumatic stress reaction because they're like, trigonometry. And they'd go into like some sort of like nightmarish remembrance of what it was like for them in school. But that won't happen to you because it's not that. But SOHCAHTOA means sine is opposite over adjacent, S-O-H. So, ha, C-A-H, cosine is adjacent over hypotenuse. TOA, tangent is opposite over adjacent. So, ha, TOA. This just reminds you, if you take the sine of an angle, the O and the A remind you which ones do I compare? Oh yeah, opposite and adjacent. If I'm looking at cosine, which ones do I compare? Oh yeah, adjacent and hypotenuse. Tangent, which one is it? That's right, it's opposite over adjacent. So, ha, TOA. So S for sine is equal to the length opposite from that angle over the length of the hypotenuse. So you could write it, so SOH, so the way that I oftentimes write it as well is I'll say S equals O over H, C equals A over H, T equals O over A. So here it is. So, ka, toa. Yeah. Before we move on, I do want to mention tangent real quick. 45, 45, 90s are isosceles, yes? What would the tangent opposite over adjacent be for a 45-degree angle? What's that? It should be the same, which means it's what? You're right, it is the same. If you put a number that's the same over itself, what do you get? 1. So, go to your calculator real quick. Type in the tangent of 45. It's 1. Because you're comparing two sides of a triangle that are the same. You're comparing two sides of an isosceles triangle. Right? We get ourselves a 45, 45, 90. And we'll call that angle A. And let's say that's 2, which means that has to be 2. The tangent of A is going to be 2 over 2, which is 1. A is 45 degrees, so the tangent of 45 is 1. All right. Let's do some math with it now. So now that you kind of have a basic understanding of what sine, cosine, and tangent mean, now we're going to do some identification. We'll start off with a nice Pythagorean triple, a 5, 12, 13 right triangle. 5 squared plus 12 squared equals 13 squared. So we can use whole numbers to start off with. This is not a 30, 60, 90. In fact, we don't know what the angles are. We'll be able to figure it out, but we don't know what they are yet. It is not a 30, 60, 90. And we know that because 5 times 2 is not 13. If this was a 30, 60, 90, if that's 5, that would be 10. So not a 30, 60, 90. What we are going to do, though, is it's kind of set up everything for us. I'm going to get some highlighters, though, so I can kind of color code everything like I like to do. Trig is so much fun. All right. Here we go. We'll call this one, we'll do yellow for 5. So every time I see 5, I'll highlight that in yellow 5. Huh, that's the main coloring in Mountain Dew. All right. We'll go with blue as 13, or blue is 12. How about that? Blue is 12, so then we'll do 12 there, 12 there, 12 there, oh, and 12 there. And then 13 is our hypotenuse. Make that one green. 13. Feel like I'm calling like a quarterback. Grade 13. All right. Right before they hike the ball, you know? Okay. So if you look at the sine of angle J, all right, this is where we're going to do some practice. Look at the sine of angle J. Sine is always opposite length over the hypotenuse. So anytime you see a letter, that is the angle you're looking for in the triangle. So start at angle J. The sine of angle J, if you look across from it, opposite, that's the 5 over the hypotenuse, which is 13. 5/13 is the ratio for the sine of angle J. The cosine of angle J, stay at angle J. Cosine is adjacent over hypotenuse. That's that ka from the SOHCAHTOA. So you look at adjacent to J, it's not 13 because that's the hypotenuse. It's 12. That's the adjacent side. So you take the adjacent side, you put it over the hypotenuse, 12/13. There it is, 12 over 13. Tangent of J, start at J, look opposite, 5 over adjacent, 12. 5/12. For angle K, sine K, opposite over adjacent, 12/13. Cosine K, adjacent over hypotenuse, 5/13. Tangent K, 12 over 5, opposite over adjacent, 12/12. And then it's just asking for decimal approximations to the nearest hundredth. So let's go ahead and fill those in. What's 5 divided by 13 rounded to the nearest 2 decimal places? Nearest two decimal places, what do we get? 5 divided by 13. 0.38. Good. 12/13. That should be close to 1. Yeah, 0.92. And then 5/12. What's 5 divided by 12 to the nearest hundredth? 0.4. 0.42. The 6 after the 1 rounds that 1 up to a 2, so 0.42. All right, now, hey, look at that. We already have 5/13 for this one, so this cosine of k will be 0.38, whereas the sine of k will be equal to the cosine of j, which is 0.92. Now this one's going to be a little bit different because now it's 12/5 instead of 5/12. So what's 12 divided by 5? It'd be 1.4, right? 2.4. Sorry, 2.4. 1.4 would be 7/5. 2.4 is... Actually, we need to make a change here on this last one because that's not approximately, that's equals. Straighten those out. No squiggles here, those are equal. Equals 2.4. All right. So if it asks you to find the ratios for sine or cosine, that's how you do it. Like if you just need the straight up numbers, that's what we're doing with that. All right. Now, we're going to go ahead and use some trigonometry along with a special right triangle, a 30, 60, 90. Any questions here before we continue? Feeling decent? Not too bad, right? Just setting up comparing side lengths of right triangles. That's it. That's mostly what this is. We will get into some equations and cross multiplying and things like that, but it's not too bad. All right, so special right triangles can be used to find the sine, cosine, and tangent of 30, 45, or 60-degree angles. So if we're using special right triangle to find trigonometric ratios, we already kind of did this. I already showed that to you on the backs of those tardy slips. Use a special right triangle to express the sine of 60 degrees as a fraction and as a decimal to the nearest hundredth. All right, so the sine of 60 is going to be opposite over hypotenuse. So if the shortest side is x, then the hypotenuse is going to be 2x, which means that the long leg is going to be x times the square root of 3. I'm not going to put those in the dotted lines. We're actually going to put the decimals in here. But if you take the sine of 60 degrees, that's going to be the opposite side across from angle 60 degrees, which is x times the square root of 3, over the hypotenuse, which is 2x, which is going to look like this. X root 3 divided by 2x. Now, x root 3 divided by 2x, these both have an x that are being multiplied on the numerator and denominator, right? If you have the same thing, whether it's a number or a variable being multiplied on both the numerator and denominator, what can you do with that? Yeah, they can cancel out. So it's root 3 over 2. Yeah. So the x's actually cancel out and you get root 3 over 2. So let's round that to the nearest hundredth. Square root of 3 divide by 2. What do you get? Point what? .87, yeah. 0.87. Which we can use. Actually, you know what? I think we were supposed to write those in there. Oh, well, that's fine. X root 3, x, and 2x. So there it is. 0.87. Now, type in sine of 60 onto your calculator. It should be, and it is, the exact same thing. Which means that this should also be equal to the cosine of 30. So also type in cos 30. Should get the same number a third time in a row. Hey, there it is. all related. All right. Questions on that? Don't see any hands up. All right, let's keep going. Yeah, we're not going to finish this today. We'll finish this up tomorrow, which is fine, which means you don't get a new assignment today, but you'll have one for tomorrow. All right, here we go. Number 3. Matthias builds a ramp so his sister can access the back door of their house. The 12-foot ramp, the ramp is 12 feet long, slopes upward from the ground at a 4-degree angle. So that's that 4-degree at angle A. What is the horizontal distance between the foot of the ramp and the house? So if we take a look here, if this was a special right triangle that we knew the actual relationship between the sides on, we could just do that. But this is a classic like trigonometry problem. We know that the length of the ramp is 12 feet. What is the height of the ramp? We need to figure out the length of y. So here's my question for you. What trig ratio should we use? Sine, cosine, or tangent? If we know that angle, and we know this side, the hypotenuse, and we know that side right there. What trig ratio should we use with angle A, which is 4 degrees? What's that? So tangent would be opposite over adjacent, which would be y over x. So it would be sine. Sine, yeah. Sine of angle A, sine of 4 is going to equal y over 12. And the whole idea here is pick a ratio where you actually know 2 of the numbers, and then the variable, the third thing, is the thing you don't know, just like any regular equation. So we know 4, we know 12. We need y, because that's the height of the ramp. Oh, we need the horizontal distance as well. So we could use sine to start off with, or we could use cosine to start off. Cosine of 4 would give us the value of x. Sine of 4 would end up helping us figure out the value of y. So we're going to have to use both sine and cosine to solve for x and y. So let's read through the process here. It's going to do the horizontal distance first. So it says the measure of angle A is 4 degrees. The horizontal distance between the ramp and the house is x, which is the measure of the leg that is adjacent to A. So x is next to angle A, that 4-degree angle. The length of the ramp is the measure of the hypotenuse, which is 12. Because the lengths of the adjacent are given and the hypotenuse is involved, then we're going to write an equation using cosine in order to solve for x. So here's how this is going to work. Everybody pay attention here. Ready to listen up? Eyes up, guys. Wake up, please. I know it's warm and you just ate lunch. Eyes up. Wake up. Wake up. I know we're sleepy. Yvonne, Caitlin, wake up. Okay. Abby, wake up. I know. Oh my gosh. So we are going to solve for x by using the cosine of angle A. And so for A, we're going to replace A with 4 because we're talking about that many degrees. A gets replaced by 4. The adjacent side is x. That's the thing we don't know. And that's going to go over the length of the hypotenuse, which we do know, which is 12. So we're going to end up writing a proportion. And it's going to say that the cosine of 4 is equal to x over 12, right here. Cosine of angle A, which is 4 degrees, equals the adjacent side, which is x, we don't know it, over the hypotenuse of 12, which we do know. Now, oftentimes, and actually not even oftentimes, pretty much all of the time, I will, if I was writing this on my own, everybody pay attention here, I would write this as the cosine of 4 over 1. And the reason why is because we're writing a proportion. So that'd be a fraction equal to a fraction. And when you have a fraction equal to a fraction, how do we solve that? Cross multiply. Yeah. So that's why I always like to have a fraction written. So just put a 1 underneath it. That makes a fraction. So if we cross multiply here, 1 times x, there's my x right there. Cosine of 4 times 12 is 12 times the cosine of 4. So the length between the edge of the ramp and the wall, the distance, the horizontal distance between the edge of the ramp and the wall is equal to 12 times the cosine of 4. So on your calculators, all you have to do is type in 12 cos 4. That's it. And so the answer here, 11.97 feet, which is exactly what we get on our calculator. So 11.97. You'll always use your calculator to figure out the answers to these because, well, we don't have any other way of doing it, frankly. So that is it. Cross multiply, solve. Sometimes you need to divide, sometimes you don't. But that is the distance, which makes sense because if the longest side of the right triangle is the hypotenuse and the hypotenuse is 12, this needs to be less than it, which it is. Not by much, but it is less. All right, let's go ahead and do one more today, and then we'll pick up tomorrow with the rest of it because that's a really good stopping place. In fact, I will assign part of the assignment. It won't be due till Monday, but I'll assign part of it today in case you want to get a head start. All right, now we got to find the height of the ramp. And we mentioned a moment ago that the height of the ramp is going to be using the sine ratio because the height is this distance here. We can still compare it to the 4-degree angle, but this time y is opposite that 4-degree angle, and we still have the hypotenuse. So opposite hypotenuse, that's going to be SOH, sine equals opposite over hypotenuse. So the sine of 4 equals y over 12. That's how we're going to write that one. And you'll see right here, it shows that the sine of 4 right here, I'm going to put that 1 underneath that as well, though, is equal to the opposite length, which is y, over the hypotenuse, which is 12. And then from there, we cross multiply. 1 times y is y. 12 times the sine of 4 is 12 times the sine of 4. And that's all you have to type into your calculator. And it says 0.84 feet, which is equal to about 10 inches. How would you get from 0.84 feet to 10 inches? By 12. There you go. 0.84 times 12 is about 10. 12 inches in a foot, 0.84 feet times 12 inches is about 10 inches. So either way, both are correct. But if it asks you to answer it in a certain way, if it asks you to answer in feet, you'd write 0.84 feet. If it asks you to answer in inches, you'd say it's about 10 inches. Something else I want to mention real quick. You don't have to type in 12 times the sine of 4. You could type in sine of 4 times 12. However, there's a reason why it's written like this instead of sine of 4 times 12, because if you don't pay attention to what you're typing in, you won't get the answer correct. So if you start with the sine, you'll notice there's a set of parentheses that it automatically opens. So if you type in sine of 4 times 12 like that, you will not get the right answer. Because this is not the sine of 4 times 12. This is the sine of 4 times 12, which is the sine of 48. We don't want the sine of 48. We want the sine of 4 times 12. This will not be 0.84. But if you type in sine of 4, close the parentheses, and then multiply by 12, you will get that 0.84. So that's why we usually put the number in front of the sine, cosine, or tangent. That way you don't have to think about closing off that parenthesis to make sure that what you write after is supposed to be after the parenthesis and not inside it. So little detail on the calculator, but it can make your life a lot easier. So that's the reason for that particular order that we do that. All right. I'm going to go ahead and pause here for the day.